Okay, I think we're ready to go. So let me swap over to here. So hi everybody, welcome to the technical steering meeting. Today we're going to hear from Taesang and Sangsik about their proposal for scalable deep packet inspection engine, both available as an on and off platform application for ONOS. So I'm just going to hand it over to you, Taesang.
Okay.
Is that right?
Okay.
Do you want to sit over here and run it from here, or do you want me to just do this?
Yeah, just
okay.
Okay. This is one of our OpenTem sub-project work, and before we did this, we completed the adaptive flow monitoring part, and this is our second phase to support DPI capabilities for ONOS. As I said, both on platform and off platform. Okay, this is our initial proposal, and we may go through several revision processes maybe in the future as well. So as you can see on this slide, ONOS packet manager subsystem, we on the very first thought, if you go to the next slide, this was our initial thought, that we add the packet capturing capabilities in the raw packet provider as part of raw packet provider, and include the packet analytics part, inspection part, as part of core of ONOS platform. Both the packet capturing capabilities and the packet inspection capabilities are based on the available open sources. We are trying to find out different kinds of options. For example, for the packet capturing, there are several packet capturing open source libraries available, many on the PCAP related ones, and there's there are PCAPs mainly because of the performance issues. They're all written either C or C++. But since ONOS platform is Java, so we try to find any Java wrapper sources, and there are several different variations, and we're trying to compare the pros and the cons of different options. And so far, basically there are three different variations. One for JDNI variation, and the other one is JNA variation. And third one that we recently found is a little bit enhancement from the JNA, because problem with JNA is the performance, and problem with JDNI is on the reliability and issues. So and there is another version which is enhancement from JNA in terms of performance, which is called Breed for Java, and there is some other variations as well. So we're considering, and then we may ask your opinions on which one will be more suitable for this work. And anyway, this was the initial thought, that we would like to add both packet capturing as a raw packet provider, and then DPI engine as part of a core service. but we found some issues that we need to resolve. And if you go to the next slide.
Just a quick question. So this would be in addition to the packet service that's parallel.
Yes,
okay.
Right. This was our very initial thought, and then we changed our mind to go other options. So it has the first one is there were several issues that we thought of. The first assumption, not only for this one, for the other options, is that the ONOS provides the redirection capabilities through the controller to our DPI subsystem.
Yeah, that's not a winning idea.
Yeah, it's currently it's not. I talked to the third person here that it's not currently available, and we may need to search for these capabilities. But Ali told me that it can be done from ONOS team. And that other issues is the current packet provider can process packets only from the controller session, not any packets, including data plane packets within an interface.
Correct. Yes.
Yeah. So also the packet services request packets applies flow rules into all switches that are managed by the controller, not selectively on particular switches or interfaces.
Yeah.
And also this approach is tightly coupled with the ONOS platform in the core part, because it may have a performance impact on the ONOS if the DPI subsystem is offloaded by a large volume of traffic to manage.
Right.
So because of this, actually, so we debated from our initial thought into other two options, which is one is on platform solution and the other is off platform. But the on platform solution is instead of putting the DPI engine in the core part, we are pushing that into the application level. And we have a DPI service manager, which can orchestrate the creation and the kind of life cycle management of DPI engine processes. And we have packet capturing processes, put that into the core part. And what it does is basically captures packets and then send it to a particular DPI engine that it can serve the DPI processes. So this is the first phase of proposal we are currently thinking of. And then it can be more than one instances of this subsystem. And if we have more than one subsystems, then the DPI service manager in one of these multiple subsystems can control the creation of raw packet dumper and DPI engines, etc. So it doesn't have to be DPI service manager, have to be all the instances of different subsystems.
Is the service manager creating threads, creating processes?
Yeah, it creates the packet dumper, which is a PCAP Java version. And also it creates a DPI engine, which is another process in the application.
So starting and monitoring processes.
Yeah, starting and monitoring, and then, yeah, that's right.
So what is the rate at which these packets are?
Excuse me?
What is the rate at which these packets need to be processed?
It depends on the data plane interfaces. If it is switchy sports, actually, basically, we are assuming the line rate performance of
The data
packets. Yeah.
Yeah. So clearly, there's some massive in-cast problem,
Yeah,
which will prevent this from working at all.
Yeah. But the
Well, no,
but the way that we
Just saying.
the way that we work is
Sugarcoated, man.
we are not capturing all the data plane packets.
Yeah.
But we are not capturing all data plane packets. This is application driven. We call selective DPI. So rather than instead of getting all the data packets, we are getting the inputs from the application on particular flows that application is interested in, and then we direct those flows data packets only to this DPI subsystem and can process it, so that it doesn't have to.
So what you're saying is that there may not be on a 512K or 512 port chassis switch, you're going to have 512 line rate flows going into a single line rate control collection.
You never do, right? Like if you
only have like.
no, but this is true for anything. Like if you take a normal switch nowadays, right? And you do port mirroring on it to capture the traffic, right? You're also stuck. You have this kind of problem, in-cast problem as well, right?
But the nice thing about it is that the hardware is actually designed to handle it.
Well, so is OpenFlow. So like the point is here is via the data plane, right? I can redirect or duplicate traffic on the data plane and send that to a process on ONOS.
Yeah.
Right? Which is what I'm doing when I'm doing port mirroring, by the way. When I do port mirroring, I send it to my machine and I have a look at this traffic. Right? Same thing here. The advantage with OpenFlow is you get to set your capture filter, right? Rather than setting it in your machine, where you get like 10 gigabits per second and you set it on your machine, you get to slice that and do it selectively, which is an advantage.
Yeah.
Maybe your worst case scenario is equivalent to the prior case. Your best case scenario is a lot better.
Okay, so can you clarify? So I guess the key thing is that when you do port mirroring, you don't send those data packets up the control connection.
Not here either.
You're not doing that here
That's
either.
not.
That's sort of the key thing.
Yeah.
Yes, and this is
Actually, it has.
Yeah, and also one more thing to add. This is a scenario one where we actually can run this just for small setup, and for simplicity, this setup can be run on platform.
Yes.
But there will be another scenario which shows how to run it off platform, and you can actually run the various DPI engine platforms in scalable fashion as basically as appliances in a network that you can scale to your demand to the level of snooping you need to do.
So when
the off platform is explained on the next slide.
Yeah.
Right.
Yes.
So maybe we should let him explain.
Exactly. I just wanted to allude to that. So that
Yeah.
two questions. One, you're filtering data packets as close to the device as possible on the device.
Yeah, that's right.
Possible. Great. You talked about the DPI service manager starting processes when it's on platform. Does that mean it's starting child processes of ONOS for these components? Or is it really when it's on platform, it's doing something different versus when it's off platform?
That's actually it's not. It's not the child process. Actually, that's the application process.
ONOS.
In the application
It's
layer.
doing an
Yeah.
exec.
So
Well, who's the parent, right? Parent's ONOS.
Is it a process or is it a thread?
Just ONOS application.
Okay, so it's just a thread.
They're starting
It's a
with
thread. Oh dear.
so when on the
In
on
the same JVM.
So okay. So
But again, this is the on platform, which is for small deployments, which is like for convenience, easy to use, right? But there's the other proposal, which he's going to get at, which is the off platform one, where it is more scalable.
Just delete the word more.
Well, you'll see. Let give him a chance, right?
Okay. Let's see.
Okay.
It's the on platform, yeah. It's
Okay.
just obviously has a lot of serious problems.
Of course,
Yeah.
but still useful.
That this is a general the workflow on the on platform case. So you can see that ONOS application in this case kind of service chaining classification is one example application. You can request the DPI start process to DPI service manager. The service manager will initiate the raw packet dumper and associated DPI engine at the application level. It will create necessary
question.
processes.
Yeah, quick question. This start request, what does it all entail in terms of, is it targeted for a specific device and for specific type of traffic, or is it, or what else, or
Yeah, the target is specific flow. So
specific flow on a, is it on a specific device or across the
across the
network?
data plane network.
Across the network.
But-
Oh,
but,
okay.
So in this case, maybe it can be a single flow or multiple flows that application requests. And then what DPI service returns to the application is that the raw packet dumpers the interface information. And ONOS application knows where is the source and destination of that particular application flow that it is interested in for DPI. And that information is conveyed to the ONOS controller. And ONOS controller will set the flow rules for the redirecting of that particular application flow, and it knows where to redirect through this information.
Cloning of the
Yeah.
flows.
And then that information can be sent to this packet.
Okay, so the application, so as part of, okay. So I'm a little bit lost. So identification of specific flows is on number 1.
Yeah.
So that's where you will actually, identify like selectors, traffic selectors, right?
That's actually
it's
given
just
from
a-
the application, yeah.
So, okay, quick question. What is the reason for decoupling that from decoupling it where it is to be installed? Because this happens in, you identify the specific flows, but not until in step 4, we actually request the redirection.
Yeah. And, through process 3, it receives the contact information about the packet dumper. Application
Okay,
doesn't
so-
know where the traffic flow information can be redirected to.
Okay.
So and also DPI service manager has to know what kind of application is interested in for DPI services. So it registers its DPI request, and DPI service manager will create the necessary packet dumper and DPI engine.
Sure, basically the
process it.
sync, right?
And
where
then-
the
yeah,
events,
yeah.
where the
And then it
packets
sends
can go.
that information to the application. And application can convey that information to ONOS controller. And when ONOS controller set the flow rules, it knows which flows it has to redirect to, and then
I see.
where it has the destination of that redirection. So those are the process 1, 2, 3.
So basically, if I were to paraphrase it, the application that's interested in monitoring some form of traffic makes first a request upfront in order to set up the sync.
Yeah.
Where the events
Yeah,
should be
that's
set up. The sync then contains the necessary addressing information, which the application can then use for redirecting the traffic.
Well,
The actual-
you shouldn't say redirect cloning. You should say duplication of traffic.
Yeah.
Yeah, actually-
You sort of nailed it. I mean,
Yeah.
This is exactly, port mirroring to a process somewhere on the network.
Exactly.
The thing is, there are a lot of problems that you need to solve to make this.
I mean, you can't just mirror your entire network traffic and hope it'll be okay. Right? That stuff doesn't happen, right? I mean, to some extent, you could have a farm of servers where they're all running this off-platform instance of
Yeah.
ONOS, and then you can redirect a whole bunch of it, but that requires extra cables. Right?
In
Yeah,
the
there's no magic
data
here, right?
plane,
Like,
actually.
the rubber has to hit the road
Yeah,
somewhere.
yeah.
right?
I mean, the key thing is, this is, like you say, it's a mirroring function and a bit of process orchestration. It's, the key idea here is expanding ONOS to do, data plane functions, which a lot of people call NFV.
Yeah, but-
and how to handle the orchestration. And the process idea is a good one, but there's,
But
the hard problems are not the
on-
ones that are on the slide.
I'll tell you what the on-platform one is useful. It's useful. It's definitely not something you would ever deploy. Just be very clear about this. You would never put it in production.
Yes.
My point is, I'm developing on ONOS. I have a problem, right? I run into some weird issue, right? Nowadays, what I do is I have to fire up Wireshark, right? And I have to correlate what I see in Wireshark with the program flow of my execution flow of my program, right? Like my execution flow in my application in ONOS, right? Like all I see in the PCAP, I have to understand, okay, this flow mod here came from this line here, and so on and so on and so on. Whereas with something that's on platform, right, I can run this DPI on my own control channel, right? And I can DPI my own. I can do a PCAP in ONOS immediately, and correlate that immediately, right? I have to add some glue code to that and add some more functionality to the on-platform version, but it gives me all the necessary tools to build that, and I can correlate any piece of code to the packet that I'm seeing on the network, and that for debugging makes your life whole bunch easier.
Yeah, what you're suggesting is a probe system for debugging, which is a good idea.
Yes,
probe.
yes,
Yeah, yeah.
exactly. And
But,
that's
I think but your point zero that you'd never use this
in
in
production.
production is
On the on-platform, the on-platform version.
Yeah.
The off-platform version, you might use them.
So this is.
Yeah, but this
off-platform,
particular subsystem here is a separate subsystem. Although it is within the same cluster of ONOS controllers, but it can be separate VMs and even separate server machine, which works passively only. It doesn't impact to the controllers.
So what do you mean by on-platform here? I mean,
It's running
It's
entirely
still-
on
still
ONOS.
is
It's
part of
running
ONOS,
inside ONOS.
So the
subsystem.
box on the right is actually running inside ONOS?
yes.
No, the
Yes.
box on the right is not running on ONOS.
Yes.
Oh, this one is?
Well,
I thought it was-
so this is a
This is the
generic.
on-platform.
This is a generic.
still-
yes,
still
yes,
on
yes,
platform?
yes.
Yes.
Yeah, this is subsystem.
Okay.
Yeah, that's why on open means completely it's external to ONOS. Yeah.
But it is just a matter of like where you place that functionality, right? And whether it is
Yeah.
inside ONOS or
Yeah, exactly.
sort of like put it outside and then, have it like
Yes.
independently.
So the DPI engines, those are something, if I want to do deep package inspection, I'd write a customized, whatever. I'd write an engine, or is that a generic engine that is somehow given a policy to run?
We try to provide generic as generic as possible,
Okay.
and then application developers can develop
extend that
further.
if they want.
Extend from that generic functionality. So at least this will give you application detail analysis, and then if you want to add further functionalities from the other analytics functionalities, I think it's up to the application, developers to.
So,
to
okay,
enhance
so there's a
that.
catalog of these engines that I can basically say, clone this flow, mirror this flow into this engine.
So it sounds like a huge amount of work to do just for debugging.
Actually, I'll leave it. Would the off box work for the debugging too, though?
For debugging of the ONOS control channel?
Yeah, the same thing. Could you use the off box one, or is that just your back into wire?
So it depends how we look at the redirection or the duplication of traffic, because in OpenFlow, you can't duplicate the control channel, right? You can't duplicate the control channel onto like, I can't put a rule that allows me to, well, no, I can't. I can't put a rule that duplicates the control
Yeah,
channel.
the big problem is.
But the
that you lose-
on-platform one, I can instantiate a DPI engine that listens to my control channel. That's different, right?
Well, the thing is, I don't think.
Actually, what he did is, for the debugging purpose of a control channel, not like ONOS on platform, but we did external way.
Mhm.
We basically reject all or mirrored all the packets within the control channel, and then perform some analysis of what kind of packet types and then how many packets and which switches generates most, and those kind of things can be done. But Ali said, this on platform can be
Okay,
so
the
that
reason
can be
why-
one
the
use
reason why
case,
it would be
but-
useful, the reason why this would be useful is because the hardest thing to trace in a PCAP is when you have a network of like 15 switches, when you look at a PCAP file, your only indication of which switch you're talking to is the IP address, and if you're unlucky, if you're like using MiniNet, for example, it's a TCP port. Go figure it out. It gets really annoying.
Well, hold on a sec. If you're using Mininet, you can TCP dump any port on any switch very easily.
No, I'm not saying it's easy or hard. I'm not saying it's easy.
I'm saying it's easy.
I'm not saying.
So a quick question on here.
I'm saying it's hard on hardware. It's easy on Mininet.
No, but if you take a PCAP, you only have port numbers to go by to map them to your switch.
No. You just like put you can. I mean, only if you're foolish enough to not create like a file name that corresponds to the switch or the port, for
So
example.
when I do a PCAP, when I do a Wireshark, I don't have the file name show.
Can I get us back on track? I mean, it's just not
It
very
shows up in the
necessarily
whole-
pertinent to what the presentation.
It shows up in the title bar.
So I had a quick
No, it
question
doesn't.
regarding to what Ali said just a little bit earlier about the capturing the traffic on a control
Control channel. Yeah, between
Is this-
controller and
when
the
it's
data.
running on platform. So the thing is, I was under the impression that whether or not we're running on platform or off platform, it's going to be, the traffic is going to be captured through,
Yes.
not on a control channel.
No, yes,
no.
yes. No. But the point is that you have the DPI engine code
Is running
on that platform.
behind the same network
Yes,
interface.
and so therefore I can attach it to that.
Yeah, got it.
Right?
Okay,
That's my
I
point.
see.
But in that case, your steps 3, step 4 would actually be different.
We change, but it gives you the ability to do that because you put it there.
And if you want, right, and if you want to
Yeah.
do that in the on the off platform one, you could also put a
Got
kind of a cloner in ONOS to clone it off to the off line.
Actually, the main purpose of DPI is for analyzing the user data traffic.
It's just
We
observing.
haven't, yeah,
It's no-
of course, we can analyze control or management traffic.
And then
For
you
debugging
analyze,
purposes.
someone puts policy on that, and that's completely controlled.
Actually, it doesn't make difference from the DPI engine point of view. Okay. Whatever
Okay.
traffic it is.
I think that would be just one. There's two aspects, right? Like it's like analyzing your user's traffic, make sure that everybody's nice and behaving nicely on the network, and not doing bad things. There's the other part where it helps debugging and development of applications in ONOS as ONOS as a platform where I can, it just helps when I can, I mean, how many times do you open Wireshark a day? I don't know. I open it a ton of times. If I don't have to, and I can correlate, and I can, once you have the DPI engine, you have the basic functionality, then you can start mapping it. You can extend this debugging framework more like to allow you to do fancier things.
Actually, the debugging, what do you mean by debugging? Is debugging during the development process or debugging in the live time? I mean,
No, so-
while it's working,
no,
you can analyze the
I honestly
traffic
think it would be
for the
That's
fault management
what we
purpose.
troubleshooting.
It's called debugging in the development environment, troubleshooting in the production environment.
Yeah.
Yeah.
Troubleshooting in the product.
Yeah, it's not really going to be that useful for troubleshooting.
It is why. I mean,
It'll be somewhat useful.
so why does port
I
mirroring
think so.
exist, right? Like
Yeah.
port
Yeah.
mirroring is super useful. Right?
What is what?
Port mirroring is super useful.
So,
Yeah, I mean, I guess unless you have a,
are we good here? Do you want to go next one?
I mean, like you said, it's the on-platform thing is not gonna fly.
So this is
This is
for
a platform scenario. As you can see, the only process in the on-platform subsystem is DPI Service Manager, and then we have external DPI capturing functionality and analysis functionality in an external box. And that can be a virtual box, or it can be dedicated hardware standalone machine, which can have enough performance and capabilities for
Yeah.
scalable purposes.
That's sort of tricky. There's sort of an irritating problem, which is that OpenFlow currently lacks data plane packet out, so you have to put in a rule per port to do mirroring. Right? You have to have mirroring. You have to tag your packets with mirroring rules, which can be a bit irritating. But to note the ingress port.
Oh, you mean initially, like the where it came in from?
Yeah.
That's not the end of the world for user plane traffic. That's not the end. That's not too bad for user plane traffic because you know.
Well, I
where
guess if you know like what port they're attached to.
Exactly. That's what I'm saying.
Yeah.
Like, if you use it,
There's a bit.
port
But I
mirror-
guess my point being that you have to either do there's additional work required if you like
which is the case nowadays for port mirroring as well.
So, I mean, this whole, I mean, I still have
I guess that's the
a
point.
slew of questions maybe we can cover later about strategies for placement of the mirroring.
Yeah,
rules,
the
right?
positioning of
Where you place
yeah.
mirroring rule, that's good, it will matter, right?
also placing where to position the DPI engine. Actually, it has to be as close as
The topology of
Yeah.
it, sure.
Yeah.
that's another issue. Yeah.
The point back,
I would recommend you punt on those for now.
No, I understand, but we ought to at least have a sort of a bucket where we know we're gonna be solving that problem.
Yeah, absolutely. But
So questions about this one, this slide.
Okay.
Why did you make the decision to put the API endpoint on platform as opposed to just having a service agent be that API endpoint? And so when I want to create engines, go to that endpoint in an external process, which then may communicate back to ONOS to set up the flows, but then you've got a separation of concerns. You've got someone who's really concerned with setting up DPI, and one of the other concern is setting up flows. Just curious why you made that decision.
Sorry, I kind of lost that.
Okay.
So you're talking about, okay, so you're saying
So
why
take the
is this?
DPI service manager and move it over to the right. Why did you keep the DPI service manager? As
You mean
on the platform?
on the platform? If we move DPI service manager completely to the external processes, let me see. The binding between the ONOS and DPI capabilities is completely separated. Actually, the application has to interact with the DPI system, external DPI system, without going through the ONOS platform.
So,
But if you have a DPI service manager on platform here, it can interact with the ONOS controller for sending requests for the redirecting the necessary flows and etc.
so
But if you are off, then those things somehow has to be connected again.
So I'm making the assumption may be completely wrong, that ONOS already has a public API to which I could set up a mirror flow.
It basically does. I mean, there's no reason why we couldn't just do a mirror intent, for example.
Well, so well, just like today, yeah, we have the ability to push flows, but
Yeah.
we still have a notion of a packet request for our packet services because, for example, packet request in case of regular control packets, it's essentially a future set of rules or flow objectives. Basically, we're saying any traffic that looks like this on a data plane, we would like to redirect. Except in the case of packet service, it's a uniform, it's a complete blanket over the entire control domain. We're very interested in basically intercepting traffic from any point on the network. There's a little bit more selection in this context, but I think it's still good to track it rather as a separate abstract entity rather than a set of actual flow rules or set of
As long as the
It may be very well
ONOS has enough capability to serve for the purpose of DPI, I mean the objective that we have here, I think that should be fine. But if not, then somehow the current ONOS has to be extended to accommodate that, or either. I mean, otherwise we have to add
There's several
another.
ways to do this. You can add a piece of API that can be very simple right now to the flow rule API, where given a flow rule, you can ask the flow system to monitor that flow rule.
Exactly. Yeah.
With an endpoint to go to.
Exactly.
And ONOS can then have the intelligence to say, this flow rule, I know it traverses the entire network, and it happens here, and here, and here. Okay, where is the closest point to that endpoint? It's a shortest path calculation. Install rules from there, right? So there's a bunch of ways. Now, deciding where you hang the abstraction is where it might be the.
Okay, so I guess what I was envisioning is that in order to be able to deal with the postponed buckets of intelligence, right? For example, first of all, where to place the receptors and where to place the mirror rules. So clearly, that's a sliding scale. You might wanna choose based on topology appropriate. It's basically two variable problem, and they both affect each other, right? And so the piece of code would be able to figure out, knowing basically having a record of what traffic is required, and maybe okay.
I would claim that where you place the receptor is very much a human decision. Right, because
Or an application
No,
decision.
actually,
I thought it was an application decision.
So what,
With an assistant.
so then you're writing an orchestrator, right? You have to have something that now spawns a piece of code, spawns a process somewhere.
Okay, so no, so
No, what
You're spawning DPI engine.
it's with the assist.
So basically you're spawning it somewhere, right? The point is you tell the system, I've spawned a receptor over here. I want to monitor this flow. Now just figure out where along this close path is the closest point to that.
Okay, so you could fix one point and then the other.
So my point was
DPI
really,
service-
can we separate these? And I think your answer is
Yes.
correct. If the API to ONOS is expressive enough so that the right side can push down the right flows externally, you can. And my preference would be, yeah, make sure ONOS has that expressiveness, and then you have the complete separation of concerns to do it. And then I'm going to come from that. I still think from a debug point of view, it'd be nice to be able to debug the control channel. And I think you add the expressiveness in the API, ONOS do that too. And then you have just a single way to deploy the solution, which is always this off-box platform.
Right, which was my preference for separating those functions and responsibilities in separate pieces, and you can always build on them. It's always easier to compose things rather than to break apart what might be a monolithic activity. Anyway, Taesang was going to say something, and we kept cutting off.
Yeah, we haven't thought much detailed intelligence like locating the receptors and then how we can figure out the port metering positions, etc. But they can be an application on top of the current ONOS, because ONOS has a global topology, and given the application's requirement on a particular source and destination, through this information that ONOS controller has, it can figure out where is the nearest point and how we can deploy the receptors. Depending on these receptors, can be DPI engine, can be virtual machine type. Then you can easily place near to the porting locations. If it is a hardware dedicated machine which cannot be adjustable, then somehow you have to find the nearest point from the network to that particular things. Those intelligence has to be part of the application of the DPI.
Having come just from KubeCon this morning, right? What you're talking about over here in terms of setting up and deploying your engines is essentially the scheduling that Kubernetes, Mesos, all these do of Docker containers. And so if you take these DPI engines and say they're a Docker container, there are already systems out there that can deal with scaling and deploying.
Right, and I was going to say, we certainly are going to go in a direction where we don't reinvent the wheel with respect to orchestrating these. So you can either have a static inventory of these, which are somehow sprinkled throughout, and then the SIP system simply just uses them, or there is some sort of a interface with a external orchestration system to be able to schedule these on demand.
Or it's a Docker compose. I mean,
there's many different ways. External.
Yeah, but
the point is external.
I think there's a real danger here that you're going to end up building scaler or schedulers and controllers, which are already in existing systems.
No, actually, we are not
to avoid it.
We are not reinventing. I mean, the wheels, if there exists already, I think we can definitely we need to reuse the ones.
Yeah, because you talk about the VM abstraction, where the agent can spin up a VM, whether it's a VM or a container, right? You just have this common abstraction, and you say, I don't care what's in your DPI expected engine, give me the same interface, and you can build it in C, Python, whatever, and it's just contained in this container.
If Docker supports that, provides that, I think we can.
You'll have to worry. You'll have to worry about throughput and networking.
So the thing is, what I wanted to preserve is I don't want to have to manage the inventory of these things or manage the life cycle of these. That would be deferred to somewhere else. But what this thing does need to have, if it's going to be orchestrated from at least if it's going to be coordinated, not orchestrated, coordinated from within an on-platform application. The on-platform application like the DPI service manager is going to have an inventory, whether static or dynamic inventory of what these things are, so that it can then use them.
Well, see, this is where I think the DPI manager goes off platform and just uses APIs on top of ONOS to set up the redirects. Personally, I see that as very clean separation there.
I think, the sort of interesting idea, right, is that usually, you don't want to use things like REST APIs for tight control plane loops, but things like mirroring tend to happen at more of a human time scale. So it's probably okay to do it that way if you want to, and that there's nothing wrong with that design. But what I'm sort of hearing from all of you is that the abstraction that you're sort of moving towards is an abstraction of flow paths or intents that allow you to do traffic mirroring. And that's sort of the way to think about it. That's the API that this app should use. And then ONOS can figure out the mechanics of how to actually do that.
Yeah.
But it's this high level abstraction of, I want this class of traffic coming from this part of my network to be mirrored to this endpoint. somewhere else, somewhere in the network. So I mean that's kind of the abstraction. That's what Aldi was saying. Although
Yeah,
yes,
that's
yeah.
right. That's
Yeah, but-
that's
but I- so I think-
simplest
so I think-
form of
so I think the
abstraction, yeah.
and as we noted, implementing it is not difficult using flow rules. So the right abstraction, the right thing to do seems to be to support this high level abstraction, and then implement it using the existing lower level abstraction.
That was the idea.
Yeah.
But the idea was not to rely on the raw, because it has additional semantics. In my
Yeah,
view.
but-
and I
but-
just keeping it as a set of loosely bound mechanism, lower level mechanisms, whether it's flow rules, group operations, or what. To me, it seems low level, and I would like to have a high level construct to basically keep track of these redirects.
Yeah, exactly. It's like a. I mean, I see. I'm calling it like a mirror intent or something.
Sure, exactly.
Yeah,
So
and
to
that
get
makes
back to,
sense.
if I may to use that as a T point to answer your question here, to answer your question. So in theory, what you suggested, actually, I think in practice, even too, what you suggested is possible already today. You can set up your receptor somewhere, whatever, C, Python, whatever you want, right? And install flow rules to redirect traffic to it. Already
You
possible.
use the flow redirect intent that doesn't exist, but yeah. you
Well,
can do that
or
today.
even use the flow rules.
Okay.
And when the flow, whatever the high level mechanism is available, you will be able to use that. So we are not precluding that mechanism. But I think there's some value in being able to have a centralized view from within the ONOS control application of what the have a centralized mechanism for spawning these engines. Now we're not taking on the responsibility of basically provisioning these. That's handled externally, but we can use them from a central location.
Yeah, I would say
to
the thing,
coordinate them.
if something else is provisioning them, that something else already has that view. And so any view that ONOS has is redundant and potentially out of sync.
Well, I guess the question
That
is.
requires an external. In order to get this capability, you have to have an external machine, external mechanism. It's possible that you could basically, that the user might go with a very straightforward situation where you basically provision 20 of these placed strategically along the network. There's a fixed inventory, doesn't require anybody else using it, and can use an onboard application to be able to correlate them much simpler. Now, maybe not as dynamic and scalable, but it's out of box ready to go solution.
I would say even using these other
Okay.
frameworks,
Okay.
XOS, whatever, you could do that externally. I think Big CM is going to cause bundling that's unnecessary.
Well,
From our point of view.
there is this. Oh, sorry.
Okay, actually, from our point of view, it doesn't make big differences as long as ONOS supports the abstraction that you just mentioned, the parametering abstraction and capabilities. We have a DPI service application that talks to that capability with our DPI engine. So it doesn't have to be actually.
Yeah. So basically, what you're calling into question are these two orange ovals.
Yeah, I think, and again, if there's some orchestration or coordination, which you really want to call here, that's again where XOS is going to rear its head, right? Because it does that kind of thing. And whether you use XOS in partnership with like a Kubernetes or Mesos or even OpenStack to spawn off these things, you can deal with that.
So, okay. So the thing is, I want to make sure we don't preclude use of those other external tools, but also I want to make sure that we also create a solution that with little extra will not require those additional dependencies on those external systems. And that's kind of what I was.
Usually you expect this manager to be, there are no big scalability demands on the orchestrator or the coordinator itself.
Today.
All it is doing is essentially asking ONOS to provide flow rules.
And exactly, and be able to orchestrate the right this piece right here.
The scalability and performance mainly related with this
user-centric.
side. Actually,
This
the
is XML
selection of a
RPC.
parametering, and those are actually
True, I mean, like,
This is XML RPC. Oh, I don't need all the things with SOAP. I'm going to build XML RPC. Oh, wait, I want security. Oh, wait, I want transactions. Oh, wait, I want this. And you have this simple mechanism that you started with continually grow until you have the complicated one that you didn't want in the first place. And if that is something that happens over and over in the industry.
so I mean, we are not saying that this will not scale, right? It's just that even if it is running on ONOS, I mean, all it is going to use is essentially the abstraction that lets you do this mirroring, as well as gets the distribution and everything for free, right? But But in some sense, it is a service that can be easily moved to a different location. I mean, if that is what you're saying.
I think my personal opinion, and that's all it really is if you build a DPI service manager that is spawning processes, you shouldn't be doing that. You're doing stuff that already has been done by other systems, and I understand the need to want simple things, but then someone's going to come and say, oh, I want this other capability on that simple thing. Oh, when one of the processes die, I want to be able to restart it. And you're going to end up on this more complicated thing. I could almost, bet his life on it. Right? And I've seen the pattern, right?
Yeah, I mean, it is a legitimate question of separation of concerns, right? And Larry Peterson has mentioned this and is very aware of it as well, and which is that how much do we want ONOS to grow to do what XOS does? And, or to grow modules or other limbs that that orchestrate XOS or something like that. And I think it's a really interesting question, and I sort of take probably the opposite view, which is that I'm not a fan of OpenStack and Docker and all that stuff, and so I'd kind of prefer that ONOS do it and do it right. And also, I think there's a lot of complexity with OpenStack, dealing with VMs and a bunch of other stuff that is sort of anathema to NFV, which probably should just be processes in C groups. But that's XOS, I think, is evolving in that direction as well, finally realizing you don't need all that extra junk, and that OpenStack is a means to an end rather than an end in itself. So, yeah, it's a very good question, but I think from my perspective is putting myself in the shoes of an application developer, I sort of like the idea that I can have well-designed APIs that are part of ONOS that I can use for both control plane SDN and data plane SDN and put them together. And so data plane SDN is what people call NFV. Port mirroring is an example. Doing this mirroring intent is an example of it. But it's very nice to not have to have half of my application using the ONOS APIs and the other half using Kubernetes APIs or using OpenStack APIs.
And it might be that DPI manager exists as an entity over on the right side and is calling things underneath it to do it.
But I share your concern with putting things like a DPI manager component into ONOS. It seems like too detailed an abstraction. It seems like a very vertical API that we don't want to do.
Okay. And look, again, my main thing here would be to take that DPI, just as I said, take it out of ONOS, put that vertical API externally.
Yeah,
my personal preference would be, I think you're going to end up where Mesos and Kubernetes is, or some terms of those needs. And so if I were doing this, and I'm not, so I can say whatever I want, I would look at those things to implement that. If the developers who are going to do this say, hey, I just want to spawn a process today and be done with it, and I don't want to deal with all that, that is, I think you're going to end up with, there's a belief you can build a better mousetrap, and you're going to end up with the same mousetrap. And you just,
but that spawn process is contained within separate subsystems, which doesn't affect the existing.
Yeah, but it's the API complexity and sort of feature bloat of ONOS, which I think is sort of the issue.
This is a process boundary, right?
This is a process boundary.
Yeah. External case, this is completely external.
So the resources that are being spawned within that process
that's right.
dynamically up onto certain capacity that's the part that's orchestrated by it, by the way. But spawning of this box will be external.
I'm talking about spawning the DPI. So I'm thinking, my drawing of this picture, I take that DPI service manager, throw it on the right side, and I use something like Kubernetes to spawn the DPI engines. That's my picture.
But DPI engines would be spawned as separate processes.
And they'd be separate processes.
Okay, but that might be too heavy.
I'm not arguing that. I'm saying if I was doing it.
Okay.
And then I'd have a line back from the right side to the blue side to do the intent flows, the redirect intent flows. Because I think that's where you're going to end up. Because all of a sudden, if you spawn these DPI engines initially as threads, I think you're going to get to the point where, in a production environment, I might have more than these, and I can have in one JVM and one process. And I'm going to want multiple processes. I think you're going to eventually get there. Are you going to get there in a month, 6 months, 12 months? I don't know. I think you'll get there.
There's some good arguments for what you're saying, right? Which is that which is that one, you don't want to reinvent the wheel. Two, people like Google are already working on solving the scalability problem. So why should we have to solve it again, when we can rely on that? Another is developers might already be familiar with that API. Why should they learn a new API? And also sort of controlling feature bloat of ONOS. So those are all good arguments for building your applications the way you describe it. I also, I think there are multiple ways of doing it, and I think, we should think carefully about. At the end of the day, the question is, what are the right abstractions, and what is the right thing to do for ONOS as a platform in its design, and also for application developers? And I think the end answer isn't clear yet. I think they're both approaches that could work well.
I agree with everything you said there. I think minimally I'd move the box to the right side though.
Yeah, well, I'd get rid of all the blue
But
boxes.
the thing is, before
They sort of bother me.
well, the thing is, before you do that, then you have to also basically each of those DPI engine per packet number. That's basically those who have to be separated in separate processes.
Before I do what? Move the box? Before I move the red circle to the right?
So Kubernetes and stuff.
Oh,
with
Kubernetes.
process
Yeah.
They'd be Docker containers. Yes.
Right. So which means that each of these is a separate container, separate process,
Yes.
whatever.
Yes.
So that you would have to break that apart before you can delegate to the external entities, because external entities are not going to.
I assumed, and maybe incorrectly, that even in this scenario, those DPI engines are separate processes.
No, they're not. They're running within a.
He said, yeah.
I thought I just said this is a process boundary. But maybe I was wrong.
Yeah.
I thought that I got a confirmation.
I thought you had said earlier the DPI engines were each separate processes in the off-box solution.
Depends on what kind of scalability that DPI engine, and what kind of volume that it has to deal with. It can be a process that has to deal with that large volume. In that case, I think it can be a separate process which runs on separate machine, not even VM, maybe machine. Or if DPI engine can handle the small volume, actually it can be within a processes. It can be
So I guess my question is, what is
so
the
depending on the traffic volume it has to deal with. I think DPI engine can be.
Does that mean I have a different DPI engine specification? And I've got two different classes of DPI service engines now. One that I spawn as a separate process and one that I spawn as a thread.
All operation and configuration and size of the DPI machine can be defined and configured by the operator, I think. So this is not our point. DPI service point. Just the important issue is the interface. The manager is with left hand must be registered.
Sure.
Because the managing the many DPI boxes or engines to interface or coordinate on all DPI engines.
So that all depends how independent you want these things to be. My impression was that basically that this was a process that could just as easily run, essentially that the components within that process could just as easily run on platform as off platform. But the reason we have an agent here so that we can address it when it is off platform, we have one agent per n things rather than having to have a separate agent for each one of those. If we were to segment it so that you basically have a one DPI engine per container or per process, then each will have to come with its own engine, and then you can you just spawn a new one every single time you want to do monitoring. But then you require somebody has to spawn it, which means who's gonna spawn it if you're not running Kubernetes.
Right, I agree. But my impression of this, my understanding of this drawing was those DPI engines are spawned processes, and so there's already this entity that is spawning these processes.
They're spawned threads, in my understanding. They're spawned resources within.
Actually, as I mentioned, I mean, it can be the software processes, or it can be a dedicated machine that deals with DPI traffic only. and if it needs such a performance.
How does the thread get created? Who creates the thread?
In this case, we have a DPI service manager. That's what we thought in this process. But
That guy, right?
No, he said.
No, he said the guy on the left.
manager will request that, and then actually the agent
agent
is
will
the
do it.
one who will create that.
So who creates the VM?
Who bootstraps it?
Well, that's why I said the VM is either created a priori, but
No.
there's a fixed thing, or through some external orchestration.
So if I have a DPI engine, that's a separate process, a separate
Okay.
VM. You don't see the service manager spawning that.
Actually, we haven't thought much details on how all the bootstrapping processes and details yet. Yeah, but
Yeah, I think
it can be.
I think
It
you want
can
to think
be.
about that.
Yeah, it can be. I told you this initial proposal,
I
and
would think that
implementation
don't know
details
everything
have
right
to
now.
be discussed.
I would think that would be one area where we would stay completely away from, so that we don't get embroiled in a problem that's in a territory that's already being solved by other orchestration solutions.
Yeah, again, the issue I have with having, I can do a thread or a process or a container, whatever you want to call it, multiple ways to do the same thing. I'm a developer. I'm writing a DPI engine. Which way do I do it? Now you've got kind of this
You're right.
fuzzy.
Okay, no, so okay,
logic, which
so
way to do it.
what I thought we were aiming for, in order to be able to run it on platform and off platform, you write, first of all, you can either create a generic one through some prescription, or by simply just supplying some sort of a standard class name, or you provide your custom class name, and it's gonna get spawned by that guy always, whether it's on platform or off platform. The agent does it.
No, I get it.
And because if you're running it on platform, then
You just
you
take
still have
that
the
orange-
DPI service, but it only has one agent, which is the on platform one. And then you spawn it. You spawn one of those.
So the minute you've tied it to threads, you said it will be written in Java.
Sure.
And by the way, how you gonna resource constrain it and everything else?
For the external DPI engines, actually, it doesn't have to be bound to any particular programming language environment. It can be completely separate.
If they're
Yeah.
spawned as threads, they're bound to Java.
Well, no.
The external ones, it doesn't have to be. Yeah, as long as the interface is
That
Java.
interface.
Then-
That
then
interface could be.
That's sufficient.
Oh, you have multiple
Yeah.
DPI service agents?
Yeah.
So is each engine instance examining like a single flow, or
Not, it can be single or multiple
Sure,
flows.
are there any
depending
placement
on-
constraints for these instances? Can I take like all those three DPI engine ovals are in one box here?
Yeah, it can be
Can I-
three different processes or threads in a single box if it deals with a small volume of traffic, or if
Or I can
yeah.
let's imagine that each of these is a container, right?
Yeah.
I can spin up like multiple containers.
Each
the
of
same
what?
box,
Each
or
of
like
the-
basically-
even I told you it can be a
Exactly.
hardware box.
The
Yeah.
sandbox is a container. Okay, great.
So I mean, I'm even talking about DPI engine itself as a container.
Yeah, that's right. Yeah, it can be. Yeah.
I mean, I can have
Well,
like
so we should
hundreds
pick.
of containers on the same box.
No, I understand, but we should pick. I'm just
I mean,
saying.
let's take like the atomic unit here, right? I mean, I cannot go lower than that. I will say that,
Right.
the engine or like that DPI engine is a container,
Mhm.
right? I can spin up these wherever I want.
Correct. But that implies that the DPI service manager has the means to spin them up.
So let's say there is some agent, whether it is on this box or whether it is outside of this whole structure, is responsible for instantiating these containers
Okay.
somewhere in the system, right? Somewhere in the network.
Sure.
Okay, and when you want to examine a flow,
Mhm.
all you do is essentially see if there is an available container.
Mhm.
If not, spin up one.
Yeah,
Now
that's
you
right.
have a
Yeah.
location for where you want to send the traffic to. Turn to ONOS and then basically
Yes.
Yes.
Yeah.
set up a rule that
Basically, what you're saying is decouple the two.
The bootstrapping is already done.
That's where.
Yeah, once the application
Decouple the two.
requests that, then we assume that the bootstrapping is
someone
done
do the
already. So the
orchestration.
containers will be, DPI engine, at least one instance DPI engine which can handle that traffic is already.
Yeah.
so when you
Or whatever, right? But just decouple the two. Someone installs a DPI engine somewhere, right? The process by which this happens can be prescribed or.
So I would suggest we define an external a wire interface for this.
A wire interface.
over the wire, basically a wire level protocol for this.
You mean
Why not-
interface
why not-
between
why not-
between
why
the
not-
ONOS
why not
ONOS
an
to the
API?
API external system? Is that
Given that we're.
I mean, why? Why? At the same time, why does this need to be defined?
If the entity that's going to be doing the orchestration or spawning of the agents, the agent's gonna have to have an endpoint somewhere. So well-known endpoint or a set of well-known endpoints.
Yeah, but it depends on what you're using, what technology you're using to spin up your.
My point was, so that, well, okay, so if you want to be able to orchestrate and request creation of these DPI engines and intercepts from within ONOS, my suggestion is provide a standard API for it, and standard component for it, and then component will be able to work with different types of agents, external agents, whether those agents are implemented using Kubernetes, some sort of homegrown system or whatnot, I don't care. But that was my motivation for wire protocol.
But see, I think that's the key question. Why is there a belief that I want to actually do this from an API to ONOS as opposed to an API
So that
to
you can
Exos?
couple control SDN and data plane SDN from within ONOS.
But why
Yes,
do
that's-
that
The
that's
same
Exos?
rationale
that's-
that Bob said.
Well, no, that I think it is an open question, right? I propose, and maybe Thomas is echoing this, that in the fullness of time, ONOS will need to deal with both data plane SDN, which is sometimes called NFV, and things in that space, as well as control plane SDN. And so we'll eventually need APIs and abstractions for both of those. It's not clear that now is the fullness of time, I guess.
And my point is,
But it's ONOS, can be ONOS, be one thing that is the control plane, and one other entity, if you will, but still under the ONOS name and label, that is the data plane stuff. And that. thing that
actually
deals
it's
with-
more than data
but
planes. It may include layer 4 above
Yeah,
middle boxes.
absolutely.
Yeah.
so
I don't think in ONOS, an API
Okay,
into ONOS.
so layer
So
four is
why
different.
are we talking about
Just saying.
why are we even talking about this subject? Because you can already do what we have today. Who's stopping you? So you're saying that you're trying to solve a problem that we shouldn't be trying to solve. Is that what you're saying?
If this can be solved today and you're trying
It
to
can be
rewrite
solved.
then why are we trying to solve the problem today then? Okay, I'll ask the question.
Well, because it's a required functionality that nobody has built yet. We're trying to build it using.
Well, you said it's already solved today, so it's built.
No. So as far as ONOS is concerned, what you're suggesting for the level of involvement of ONOS in this solution, ONOS is done with its part.
Okay.
Well, there's one key,
It's nobody.
Someone can still build the solution.
there's a
doesn't
missing
have to be
part
ONOS.
though.
Right.
Thomas,
That's
the mirror intent abstraction doesn't currently
Doesn't
exist,
exist.
right?
Yeah.
So that's clearly a missing, there's a missing abstraction in pizza functionality in ONOS from the control plane orchestration, right? Which is clearly ONOS's sphere of influence that's missing today. And I think there's consensus in this room that we need and want that abstraction and functionality probably.
Probably not an intent, though. I don't want to call it a shitstorm.
So there's one.
Actually, from DPI work point of view, actually, there was the assumption that
It
ONOS
might be a parallel.
provides it. But anyway,
You thought this was a simple
Yeah, I mean,
project
no, no,
proposal.
whole
That's all.
discussion is actually not in this side.
So Tama, so a couple of things that we can at least get back on the same thing that we agree. So what today ONOS provides basically everything, I guess. But for this mechanism, at least for the if we're suggesting is that ONOS is not at all involved directly with scheduling these things or even the existence of the DPI engines, then ONOS is done because we have flow rules and intents that can be used to essentially mirror traffic.
But we don't currently
But-
have parallel composition of flow rules for mirroring, right? Or a mirroring intent, whatever your abstraction you want to do, right? And that's
But you
what
can set
I
up
think
port groups
and
and
I
you
are
have-
saying is that we're
You
missing.
can do a lot of things.
Yeah.
I mean,
Yeah, so we do agree that there would be value in that we set up some sort of a mirroring abstraction, mirroring request.
Yeah, it's a
Great.
missing
So
abstraction.
great, so that's one thing that ONOS should do,
Yeah.
independently of anything else.
Yes.
Complete agreement, at least for me.
Okay.
My point here is that I think we want to go beyond that. We want to be able to, at least, I personally don't want to prevent anybody externally being able to build their own DPI engines or anything like that and orchestrate them however they want using whatever external and very, very scalable mechanisms. No problem with that. However, if somebody doesn't do that and doesn't make it accessible to ONOS applications, it doesn't exist for ONOS users. And I would like to make this accessible to ONOS users. For that reason, I'm suggesting that we set up basically a DPI service, which is an interface, which is backed by a simple, basically manager component that provides some way of spawning these DPI engines. Now, it doesn't spawn them directly, but rather it spawns them with the help of a DPI
External
agent, some sort of an
yeah.
external agent. Now, if you want that agent to be to not be Java, let's say, right?
Yeah.
Then for that reason, I suggested to have some sort of a simple wire protocol, REST. We can say it's a REST API or gRPC or whatnot, that basically allows ability to manage lifecycle of these things, to be able to create them, destroy them at a specific endpoint, and to be able to get an inventory. It's a simple resource, web resource or gRPC.
Yeah.
And that's all I was suggesting. And that way, we have the flexibility to have it either in a very, very simple scenario with single on-platform application. It can be also in a little medium complexity scenario where you can still access this using ONOS, but some external agents. Or you can have it in some different highly scalable scenario where ONOS is not dealing with this stuff at all and somebody else is orchestrating.
Again, you guys developed it, you're the architect. I don't think there should be an API in front of us to do this. I think ONOS should stick to that mirroring API. And if I wanted it as a simple thing, start up another process, start up a Docker, and then call it REST API and all this to redirect the traffic. And that's what it should be.
This is an application, right? This is not a core.
Yeah,
ONOS
it's an
API,
application.
right?
It's an application. It's
You
an
can take an
function.
application and run it somewhere else, but this is by running on ONOS, it is just sort of.
Well, but I guess what Thomas, you seem to be suggesting, which I think David is objecting to, is that we go forward, and I think it's slightly different than what I'm saying, which is that we go forward with ONOS and implement an abstraction for I guess data plane computation orchestration, for lack of a better term, create an abstraction, an API, which is a core ONOS API, rather than something that is just developed by me in my application, and that maybe my friends use it, but it's not a core ONOS thing.
Well, I was actually I think the plan is to develop this as an optional application. Now we have a lot of built-in applications, right? The reason we build things as applications in ONOS is not necessarily because they're on a periphery, but because it makes them selectable at runtime, which means we have the code written, but people don't have to run it unless they're interested in it. And so I think this would fall into that category. We would write this as basically this open DPI app would have its own set of components and interfaces. Would have probably an API bundle so that other people can code against it if they wanted to, but then you would ignite it or not, depending on whether you wanted it or not. And that's it. It's not really part of the core per se, but it's a selectable function.
If it's not part of the core, I don't think we need to discuss it, but I would suggest that if it's something that is going to be called by multiple applications, that you want something that's a little bit more abstracted, and something that's, if you want to evolve towards this idea that a core feature of ONOS is orchestrating data plane SDN and NFV, then you want to think more clearly about what this abstraction would look like and how it would deal with things that aren't with other sorts of data plane and middle box functionality, not just DPI, but other sorts of things that you might want to have, like encryption or compression or
I guess my
ambition
right this one time is not, to me that would be stepping too much in the territory of XOS and other
that's where you're going. The question is, do you want to make a vertical API that's only usable for one application?
No.
Or do you want to make a more flexible API which is usable for multiple data plane SDN/NFV applications? Because this is clearly a data plane SDN/NFV application.
No,
the question is, do you want to make an API and abstraction that just is vertical for that app, or do you want to make an abstraction for multiple kinds of things? I think you want to go in the other direction.
So I guess
no, I see where you're heading, and I definitely see applicability for this in a broader sense. For now, my thought was to come up with a solution, because I mean, Taesang, these guys are interested in building a DBI engine. So my thought was to, rather than the original plan, which was to build it on platform, which we agree doesn't scale well, right? And so the thought was to come up with a way to build it as an ONOS application and provide them with feedback to structure it in a way where it offers the least amount of, the most amount of flexibility, I guess, with respect to external entities. But also at the same time, it would be focused enough that would be focusing on this specific problem. I think we could generalize it to adapt it to other SDN functions later on, data plane SDN functions. Right now, it's just a DPI.
But are you agreeing with David in that the idea is that the only changes to the ONOS core would be adding the mirroring abstraction?
The core, yes.
Yeah, in the core, but
So I think there's sort of a bit of consensus, and I think the other piece of consensus is that you can do what you want, whatever you want in an application, and we don't need to talk about it. And we can talk about it, but it's sort of not relevant to the ONOS technical steering team. We can give you advice.
It is a little bit, because I mean, this is part of the, I mean, we've talked about other things that are not applications, right, that are applications that are not part of core. They're important. Just because it's not part of the core, it doesn't necessarily mean it's not important.
That's one thing I want to ask too. I mean, not in the core part, but even in the applications, I think there are two different categories of applications. One is the one pure specific to the user centric application, or some application that is common across different kind of user applications, which can be used by many applications.
Yeah,
I think
DPI
application is one of such cases. It can be used for multiple applications: security application, fault application, and charging application. Those all can utilize the DPI functionality. So although it is an application, but it can be used for many different purposes.
Yeah,
So in that case, that's common.
a system application, but to be sort of promoted as to part of ONOS proper, I think you'd have to demonstrate that it's really the right abstraction, and that it is widely usable by multiple applications.
That's an acceptable model. You start off as an application.
Yeah.
And if you become widely used as a service provider of some sort, then you get promoted into the ONOS core. It's fine. And on that note, I don't want to be a party pooper, but it's 420.
But you are,
Yeah.
So that means you have something to do outside.
Well, yeah.
It's just saying.
I mean, it's also, yeah, I don't know. I mean, we're free to continue because we're all adults. We're all consenting.
But he's leaving.
Yeah. But I mean, I don't know how long you want to beat a dead cat. Or dead rabbit. I don't know what the hell, which animal would beat one.
Beat a dead horse.
It's on horse.
I thought that was the idiom.
Well, the thing is, we never let you finish. I mean, but I think that did we cover the amount of detail that you wanted? Because you have further detail lower down the road, right?
Actually, there's two parts. One is on DPI itself, specific DPI itself, and the other one is port mirroring and redirection, which ONOS has to help with.
Yes.
But it seems that discussion is mostly to the latter rather than the former. But anyway, our main focus is actually dealing with the DPI engine functionality itself. But yeah, through this discussion, yeah, we learned a lot from the ONOS itself, and it seems that, I mean, you don't want to have a tighter coupling, I mean, between the DPI engine's complexity with the current ONOS core problem. But as long as you can provide the abstraction that you just mentioned, the port mirroring abstraction, plus the application capabilities, the common application capabilities, then I think from the DPI engine perspective, it should be sufficient. So,
Yeah. So
we can assume that functionality will be provided in the future, and we can work on the engine part.
Yeah, we'll have to definitely figure out what the right abstraction is.
for the port mirroring. So. Because it's the idea is that it's somewhat targeted, right? It could be targeted from single or multiple points potentially, and we'll have to probably discuss that separately.
Sure.
Right.
You'll agree to anything right now as long as you get out the door.
I feel like I'm the horse.
All right.
Or the rabbit.
Okay. So I guess with that we can probably just wrap up the meeting. So what do you think are the next steps then?
The main purpose of this proposal actually for this meeting was to get your opinion on our proposal and how to proceed from this. If you go to the next slide, further down. This is a combined one, but it can be. We can have a DPI service manager which can serve for both on and off platform, but it seems that there's some complexity involved here, so we need further discussions on this approach.
Yeah, I would probably have offline discussions to basically we could bring more symmetry into this and then figure out what is an application.
Yeah, we need to figure out use case for the on platform. As Aliza said, if it is only for debugging purpose or control channel, we can do that.
But I think that's key though too. I think even when you're off platform, the API that provides the redirection or cloning abstraction,
definitely
needs
can
to
do
be
that.
able to deal with the control channel as well as the data channel.
Definitely can
even
do
if
that,
it's faking it.
Yeah. And then if you go further, next slide here. Scalable. I think we discussed this already.
Yes, we covered that. Yep.
Yeah. Could you go to the next steps? Yeah. What we thought is we tried to develop simple and on ONOS platform first, and then go further into the external solutions from our point of view. But also both of them is based on the assumption that the port mirroring from the ONOS is provided, so that we can work on the DPI engine aspect only. So,
and is the thing is with the port mirroring, is that something that you could help work on as well, or is it something that you don't think you have the bandwidth for?
If possible, we try to avoid it, but
okay.
If you can, your team can help on this. Will be better to pay much attention on the DPI engine itself.
Okay.
But because we also have a quite limited resources.
Got it. Makes sense. Okay. All right. Is okay.
Yeah.
That's it. All right. Well, thank you very much. All right. This was good discussion. Thanks. Okay, we're gonna close up the recording and we'll see you next week.